So yesterday we were discussing about the architecture of system on chip. Okay, so different elements of system on chip are central processing unit, digital signal processor, network interface circuit, audio interface circuit, USB interface circuit, video interface circuit, direct memory access, multimedia, encoders, decoders, memory, and secondary storage. So, all these are the important elements of the system on chip. Okay, so let us see uh, each component one by one. Okay, so first let us discuss about the processors which are present on the SoC. So SoC may be a single processor system, or it can be a multi-processor system. Okay, so in single processor system there can be at least one processor core, but mostly the system on chips are having more than one core processors. And these core processors, they may be, as you can see here, they may be microcontroller, microprocessor, digital signal processor, application specific instruction set processor. So ASIP processor, microprocessor, digital signal processor, microcontroller, or ASIPs. So these type of multiple processors, they are present on system on chip. Basically, ASIPs have instruction set. Those are customized for a particular application. Okay. Now let us see about the architecture of the processors which are used on system on chip. Generally, whether it may be single core or whether it may be a multi-core type of system on chip, typically it uses the RISC architecture. Okay, that is reduced instruction set computer architecture. So this RISC architecture is advantageous over your traditional CISC architecture, that is complicated instruction set computer. And that advantage is that RISC architecture requires less amount of circuit, and therefore less power is consumed by the processors which are present on the board. And as this is very important for embedded applications and mobile computing applications. So RISC architecture is followed for system on chip. Okay. So because mostly these embedded and mobile computing application, they are often their power requirements are very strict. So in particular, SoC processor cores, uh, generally they use what is called as ARM architecture. And this ARM architecture is also called as soft processor architecture, uh, because this is also more power efficient. It follows RISC architecture, and it is more efficient than your Intel x86 CISC type of architecture. So what you have to remember about processor cores is that it may be a single processor core, it may be multiple processor core. It has microcontroller, microprocessor, DSP, ASIC. It follows the RISC architecture, and RISC architecture is for simplicity and power efficiency. So this is what you have to remember about the processor cores which are present on the system on chip. Now let us go to the next component of your system on chip, and that is nothing but the memory. So as we have seen, the semiconductor memories are used, and these memories are used obviously for storage purpose, and they are also used for performing computation. So intermediate results may also be stored there, data may be stored there. So for all these purpose, memory is used. Semiconductor memory technology is used here. Basically, three types of memory they are used here, four types rather. That is read-only memory, random access memory, electrically erasable, programmable read-only memory, and flash memory. So these all four types of memories, they may be present on system on chip. Okay, so for as we have seen further, a RAM can be divided into two types, that is static RAM, which is fast and expensive, and dynamic RAM, which is slower than static RAM, but it is cheaper as compared to static RAM. Okay, so generally system on a chip may follow memory hierarchy. It may not follow memory hierarchy. It may follow memory hierarchy. So if you are going for mobile computing, then memory hierarchy is generally followed. But for embedded system application, there is no need of a memory hierarchy there. But if you consider memory hierarchy, then you can see that the most expensive and fastest type of SRAM is used to implement the processor's register. Okay, so they are responsible for various calculations. They are acting as scratch pad of your processor. And it is also used to implement level 1 cache. Okay, so other levels of memory, they generally use dynamic type of RAM. Okay, so next to the cache is your main memory. So this main memory generally is made with dynamic RAM type of technology. Okay, so here as you can see, there may be single processor. If there is a single processor, then there will be a dedicated memory chip. But if multiple processors are there in system on chip, then distributed memory is used. Okay, and for distributed memory, there is intermodal communication chip, and this intermodal communication chip is used for the communication within the memory. Okay, so that is what you have to remember about the memory in case of your system on chip. Okay, so what you have to remember: ROM is there, RAM is there, SRAM is there, DRAM is there, EEPROM is there, flash memory is there. It may be a dedicated memory or it may be distributed memory, depending on the architecture of SoC, whether it is single core processor or multiple core processors. Okay, so this is all about the memory system which is present on your system on chip. Now, let us go to the different types of interfaces which are present on system on chip. Okay, so first, can you tell me what is meaning of interface and why it is required?
For communication purpose.
Yes, it is required for communication purpose, but why? Processor need to communicate to the external world, and they are going to communicate to the external world through interface, and interface is going to match, going to provide match between the technologies of your processor and technologies of the other devices, and these all other devices, they come in variety of technology. So that needs to be made compatible with your processor technology. So for that reason, interfaces are used. Okay, so such interfaces are external interfaces are present on your system on chip. Okay, so typically you can see the various communication protocols, standard protocols which are available in the market. They are available as interface on your system on chip. For example, if you consider industry standards such as your USB bus, Firewire, Ethernet, USART, SPI, HDMI, I2C. So all these interfaces, they are present on your system on chip. Okay, so their combination, it will depend on the application for which that particular system on chip is intended. So depending on the application, the number of interfaces to be included within your system on chip, it matters or it depends. Okay, so for wireless communication, so all these things, they were for wired communication. So for wired communication, USB is available, Firewire is available, Ethernet, UART, SPI, HDMI, I2C, etc. They are available to connect the different external devices, starting from simple mic to camera and high definition displays. Okay, so if you consider wireless uh, communication or wireless application. So wireless interfaces are also provided there. Standard wireless protocols which are available, such as Wi-Fi, Bluetooth. One more protocol is there, which is low power protocol. Generally it is called as 6 low personal area network. This we are going to study in detail in your Internet of Things. So it is used in Internet of Things. So such wireless communication protocol is also available there. For near field communication, interfaces are also available. So an example of the near field communication are optical communication, and it may be infrared communication also. Okay, so as per the requirement, the system on chips, they will include data converters, because as you know, digital signal processor is the most important part of your system on chip. So this digital signal processor, it will always require analog to digital converters and digital to analog converters in order to interface, to be able to interface with different types of sensors, different types of actuators. Okay, so basically data is collected from sensors, and it is processed and it is made available to actuators. So that is what is done. So when data is acquired from sensor, it has to be converted to digital form in order to process it. After processing, the data is available in the digital form, and in order to operate the actuator, the data need to be converted into analog form. So for that purpose, digital to analog converter is also used. Okay, there are certain application specific modules which may be present on your system on chip. Okay, so sometimes this system on chip, they may also have analog sensors which are built into SOC. Okay, so for such analog sensors which are built in on your SOC, we need analog to digital converter. Okay, and then mathematical processing of such signals is necessary, and for this we need it in the digital form. So apart from all communication interfaces, the data converter interfaces are also available on your system on chip, that is analog to digital converter interface and digital to analog converter interface. So they are available there. Okay, now let us move to the next point, which is a very important point, as you can see here, that is regarding the digital signal processor. So digital signal processor is one of the important component of your system on chip. Okay, so what this digital signal processor is, it is used to perform signal processing application. So generally what is done, the signal is acquired from number of sensors, and the acquired signal may not be in the desired form. So to convert it into the desired form, what has to be done is several mathematical operations has to be carried out over the signal. And these mathematical operations can be carried out on the signal with the help of a special type of processor, which is called as digital signal processor. So these digital signal processor, they are having a special type of architecture. Okay, so they are capable of operating on the signals which are available from a sensor, which should be given to actuator uh, for data collection, for data analysis, for multimedia processing. So all these things will require the digital signal processing. And this digital signal processor follows architecture which is called as VLIW. So VLIW means very long instruction word. So you have studied different types of instructions. At the most you might have seen 4 byte instructions, but longer than these instructions are also used in digital signal processing course. Okay, so such greater length instructions are called as very long instruction word. Okay, and they are following the architecture which is called as single instruction and multiple data. That means if there is a single instruction, multiple datas are applied to this single instruction. And this type of architecture is called as a single instruction multiple data SIMD type architecture. So what is the main objective of VLIW architecture and SIMD architecture? Is that introducing parallel processing at the instruction level. So instructions are executed by applying parallel processing technique, and sometimes it is also called as a superscalar architecture. So in superscalar architecture, generally the instructions are divided into integer instructions and floating point instructions. So with the help of superscalar architecture, 2 integer instructions and 1 floating point instruction can be executed parallelly or simultaneously. Okay, so such type of superscalar architecture is used, and very long instruction word architecture is also used. That means single instruction is going to multiply, add, accumulate, and provide output. So number of multiple operations can be carried out with the help of a single instruction. So this architecture is followed in your digital signal processing. So why this DSP course requires such type of operation? Because the DSP core is generally performing mathematical operations on the signal, and these mathematical operations, they include multiply and accumulate. You might have heard about the Fourier transform. So converting a signal from one domain to another domain, from time domain to frequency domain. So for this reason, we require what is called as transform. And transforms are basically used to simplify the calculations, because the calculations which are carried out over the signal are they are pretty complicated, and to convert these complicated operations into simple operations, the various types of transforms are implemented in DSP core processors. You can take example of logarithm, isn't it? So if you using logarithm, if you perform multiplication, then complicated multiplication operation can be converted into simple addition operation. So addition is simple to perform as compared to multiplication, isn't it? Because you have to remember tables for multiplication, but addition you can do easily. So the way logarithm converts complicated operation like multiplication and division into simple operations like addition and subtraction, in the similar way various type of transforms are used in digital signal processing to simplify the mathematical operations, and these Fourier transforms has to be done. Multiply accumulate operation has to be done. Fused multiply addition has to be done. There is one more complicated operation which is called as convolution. And this convolution is one main operation of your digital signal processors. So convolutions are performed. To suit for all these type of mathematical operations, the very long instruction word type of architecture is used, and this architecture is used to introduce parallel processing at the instruction level. So various stages of instruction, they are executed parallelly. Number of instructions can be executed parallelly. That is introduced by use of what is called as superscalar architecture. So basically, superscalar architecture was used in Intel processors. So their integer and floating point instructions could be executed simultaneously. So the same thing is applied in case of digital signal processor cores. Okay. So what you have to remember here for examination is that the digital signal processor cores, they generally perform the signal processing operations. So why signal processing operations are required? Because to convert the data from sensor, to make available appropriate data for actuator, huge data collection is required, data analysis is required, multimedia signal processing is required. For all these purpose, extensive mathematical computations has to be carried out, and those can be carried out with the help of special type of processor. Okay, simple microprocessor cannot be used for this. It will take very, very long time to implement these mathematical operations. So specialized processor which follows special architecture is used as a digital signal processor core. You can call it as a ASIP. DSP processor is example of ASIP, that is application specific instruction set processor, because this DSP processor is intended for a specific application, and that specific application is signal processing. And for signal processing, to carry out multiply, accumulate, fast Fourier transform, convolution, etc., a specialized instruction set is there. Okay, so for this reason, the digital signal processors, they are present on system on chip. Okay, have you any doubt?
मॅम
हा बोला.
सीपीयू आणि डीएसपी मध्ये फरक काय?
सीपीयू आणि डीएसपी मध्ये फरक आहे. सीपीयू काय करतो, पूर्ण सिस्टीमचं कंट्रोल करतो, ओव्हरऑल कंट्रोल ऑपरेशनचं. आणि डीएसपी काय करतो, फक्त आणि फक्त सिग्नल प्रोसेसिंग ऑपरेशन्स करतो, बाकी कोणत्या करत नाही. येतं लक्षात?
हो मॅम.
हा, म्हणजे सीपीयू हा जनरल ऑपरेशन साठी आहे आणि डीएसपी हा एक स्पेशल ऑपरेशन, स्पेशल टाइप ऑफ ऑपरेशन साठी आहे. आणि सगळ्या ऍप्लिकेशन मध्ये मोस्टली सिग्नल प्रोसेसिंग हे लागतच लागतं. म्हणजे मल्टीमीडिया जर तुम्ही कन्सिडर केलं तर त्याच्यामध्ये किती सिग्नल प्रोसेसिंग आहे. म्हणजे इवन डेटा कॉम्प्रेशन इट इज ऑल्सो अ पार्ट ऑफ सिग्नल प्रोसेसिंग. तर खूप सारं सिग्नल प्रोसेसिंग तिथे कॅरी आउट केलं जातं आणि त्या सिग्नल प्रोसेसिंग मुळेच जो काही तुम्हाला डिझायर्ड फॉर्म मध्ये, डिस्प्लेबल फॉर्म मध्ये डेटा मिळतो आणि तुमच्या सिस्टीमची एफिशियन्सी आणि परफॉर्मन्स तो वाढवतो. कारण कॉम्प्रेशन वगैरे हे टेक्निक तिथे अप्लाय केली जातात. ओके, तर म्हणजे मेमरीची एफिशियन्सी वाढवली जाते किंवा परफॉर्मन्स वाढवला जातो तुमच्या ओव्हरऑल सिस्टीमचा डिजिटल सिग्नल प्रोसेसर वापरून. ओके, now let us go to next component. Okay, so some other components which are present on your system on chip, they are timing sources. Okay, timing sources for generation of clock signal. So basically, for generation of clock signal, crystal oscillators along with a circuit, closed loop control circuit, which is called as phased lock loop. So oscillator along with phase lock loop provides accurate and stable frequency for as a timing source for your system on chip. Okay, so this is very important because everything depends on this. Now, apart from this requirement, it also has some other peripherals such as counter timer. They are also required. Timer is required for setting various timings. Counter is required. For example, it can be used for sequencing of the events. Okay, so counter timers are there, and at the same time, real time timers are there. Okay, so real time timers are very important and they are present in your system on chip. And at the same time, power on reset generators are also they must be made available onto your circuit. So whenever you power on the system, it should be resetted. It will start from your start. That is what you can say. Okay, so it may also include power management system, and in this power management system, voltage regulators are generally used. They are used to provide stable voltage source to your different components. Okay, now coming to the next component, because as you can see on the system on chip, there are a number of modules or number of execution units which are present on the system on chip. Okay, so the communication must take place between these number of units, and this communication must be controlled with help of something. That means some system must be there. Some system must be there to make enable the communication between different units of a system on chip. Okay, so this system is called as a communication subsystem. So basically, your communication subsystem must be bus type of architecture. It may follow bus type of architecture, or it may also follow network on chip type of architecture. So bus type of architecture means what? Your general microprocessors for communication, they follow bus type of architecture. That means it is having three type of buses: data bus, address bus, control bus, to communicate with the different components within the system. And it has dedicated controller which is called as bus controller, and this bus controller is going to control the overall functioning of these buses. Okay, to whom the control of data bus is given, to whom the control of address bus has to be given, which control signals has to be activated. All these things are decided by the bus controller, and such architecture is called as bus based architecture. So initially for system on chips, the bus based architecture was used, but with more and more integration, the number of modules which are present on your system on chip, they go on increasing. And when the number of modules go on increasing, then there can be bottleneck with help of this bus architecture. So bus contention may take place. So which may lead to the less performance of the system, and therefore there is a need of some advanced technology for communication, and this advanced technology for communication is called as a network on chip. Okay, so nowadays instead of bus architecture for intermodal communication, the network on chip is generally used, and this is also a topic of research. It is under development, but still it is used. Network on chip is used where you are going to have a greater amount of integration in system on chip. For smaller amount of integration, the bus based architecture will do. That is well. But for greater integration, that is including more and more models in your system on chip, you will require a dedicated network control called as network on chip. So, and that is what can be used in system on chip. Okay, the same thing is explained again here. So, for bus based communication, uh, a particular type of bus is used, that you need to remember this for examination. A very common bus for SOC communication is ARM's royalty free advanced microcontroller bus architecture standard is used. So it is, as you can see, it is open where, and therefore AMPA standard is used for bus based architecture of system on chip. Okay, so this is what you have to remember. Now, one more thing you can observe in your system on chip is, that is direct memory access. Okay, so this direct memory access process can be used. And again, this direct memory access process is used for performance improvement or performance enhancement. That is what we can say. So when external device want to communicate with the memory which is present in system on chip, then with the help of DMA process, it is not going to involve the central processing unit in the data transfer between the external device and the memory of the system on chip. The data transfer directly takes place between external device and the internal memory of system on chip. So this type of data communication is called as a direct memory access. And as CPU is not involved in this, there is no burden of this data transfer on CPU, and CPU is free to carry out other functions. And therefore, this improves the performance of CPU. Okay, so such direct memory access is provided on system on chip. Okay, so this increases the data throughput. So amount of data that can be transmitted, amount of number of instructions, those can be executed. Similarly, the rate of the data at which the data transfer between external device and internal memory takes place, everything is going to increase with help of this direct memory access. Only what CPU does is it initiates the direct memory access and then it leaves control over it, and dedicatedly the external interface and internal memory, they are going to communicate with each other and transmit and receive the data or exchange the data. That is what you can say. So this is available on your direct memory access. Okay, so as you can see, actually, bus-based architecture is limited for scalability. That is, if you are going to increase the number of cores, then you cannot use computer bus system or bus-based architecture, because it will make the overall system very slow, and which is not required. So for this purpose, what is done is generally the network on chip is used. So that is what we have studied. So as long as your wire connections are concerned, scalability of wire connections is concerned, the length of increase in wire can increase the power consumption. Okay, so longer wire consume larger amount of electrical power. Okay, so these connections must be as much short as possible to save the power, because saving power is very important in case of embedded and mobile computing applications. Okay, so this is all about bus based architecture. Now let us move to the network on chip. Okay, so in somewhere during 2010, uh, actually earlier communication was carried out by using bus based protocols. Okay, And as a trend of including more processors on system on chip uh, has been introduced, uh, the efficiency, communication efficiency between various modules of the system which are present in SOC, uh, it has become of concern. Okay, so if the traditional bus-based architecture is replaced by a system which is called as network on chip, and this network on chip allows the intercommunication between the different modules by using router based communication, which is called as packet switching. So packet switching will be suitable as compared to your regular bus architecture, and this is going to overcome the bottleneck which was otherwise would occur in simple bus based architecture. Okay, so it provides the power efficiency, it reduces bus contention. Bus contention means bottleneck of the bus. Okay, and this network on chip, it has its own architecture, and this architecture has been built from your standard TCP/IP protocol suite. Okay, so all the layers of TCP/IP protocols are not there in NOC, but fewer layers are used, and these fewer levels they are operating in line with your TCP/IP protocol. So if you are using this TCP/IP protocol, which is intended for big networks, if you are using it in system on chip, then the performance of overall communication between the different modules which are connected into system on chip, it will become efficient. This communication will become